All right, guys. Quiz 17. Focus, 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 focus. So the first few questions, I think the first two, maybe even the first three, are not even calculus. They're just, do you know what an inverse function is? So that's what the first three are talking about. So arc cosecant. Arc cosecant is an inverse cosecant. You can also say arc cosecant. The first thing I would do is I think I would turn this into arcsine. Chop, how do you do that? Because really, okay, I guess let's start from the beginning. What does it even mean? So if I write this, if I write, let's see, I'm going to equal this to x. X equals arc cosecant CSC of 2 square root of 3 over 3. What this means is this. It means, what does it mean? It means, it means cosecant of some angle equals, I guess the angle is x in this case because they have an x in there. Cosecant of some angle x is equal to 2 square root of 3 over 3. That's what it means. That's what it means. And I guess I should have written y, but it doesn't matter. Y, x, theta, whatever. So what I would have done is I would take this and I would do the reciprocal of cosecant. The reciprocal of cosecant is sine. So I would write sine x equals 3 over 2 square root of 3. And I know what you're thinking. You're looking at it like, Chav, I don't recognize that at all. Well, let's multiply this sucker by square root of 3 over square root of 3, and look what you get. 3 square root of 3 over 2 times 3. The 3's cancel out. Do you recognize it now? I don't know why I said it like that. But, it's square root of 3 over 2. So sine of what angle gives you square root of 3 over 2? And look specifically between quadrant 1 and quadrant 4. No? No one? Sine's a y value, right? What's the radian? Yeah, pi over 3. And there's the answer. Pi over 3. Do you guys see how we did it? So that's all it means. That's what it means, guys. It just means that. I would just remember what's the key here? I would turn into sine into something that you guys know. I won't turn into sine or cosine or tangent. What's up, Zalali? Tell me. Yeah. You could have also done this, guys. Arc sine of square root of 3 over 2. See? Oh, okay. Where is it square root of 3 over 2? Pi over 3. That's the output. See? Do you see what we did? What's up? So arc cosine is just, or cosecant is sine. The reciprocal of cosecant is sine. So that's why, yeah, the reciprocal. Yeah, this, when you see the -1, that's inverse. For numbers, you can say reciprocal. For functions, like what I'm saying is this: 1 over cosecant x is sine x. This is called reciprocal. Yeah. And so cosecant, I just took the reciprocal of this number. See, 2 over square root of 3 over 3, and I just rationalized it. 3 over 2 square root of 3, and then rationalized square root of 3 times square root of 3, square root of 3 over 2. Does that make sense? Cool. Yeah, if you recognize it. But that 2 over square root of 3, no. Oh, yeah. 2 over square root of 3. Yeah. Yeah. Perfect. Yeah. 2 over square root of 3 rationalized is 2 square root of 3 over 3. Yes. By the way, I don't think this is necessarily super extremely important. Remember, this has several answers. You could have also said 2 pi over 3. But they're talking about like the range of your inverse trig, the primary branch, that's what it's called. And it's negative pi over 2 to pi over 2. It's the same thing for arctan. And then for the range for arc cosine is 0 to pi. I don't think that's going to be a big deal. Just think about it a little bit. You'll be fine. Okay. So sine of 17 pi over 6. What value does this give you? So this is going back to like when you had unit circle quizzes. So I'm going to write sine. So first do the inside, right? 17 pi over 6. So what is that? Well, first let's see what 17 pi over 6 is. I know that 12 pi over 6 is 1 revolution because 12 divided by 6 is 2 pi. And if I add, because I put an equal sign here, so 12 plus what is 17? 5. So 5 pi over 6. So that means, and I'll slow down, that means that this is equivalent to saying sine of 5 pi over 6. Does that make sense to you guys? Because I just did this. Okay, I know, I see you, Maddie. This is just this. On the unit circle, I did a whole revolution. There's my 2 pi. And then I went another. Whoop. So there I am at 5 pi over 6. So, well, this is 2 pi, right? So this, you can actually say that's like your terminal angle from pre-cal, remember? So 5 pi over 6 and 17 pi over 6 aim in the same direction. So do you know what sine of 5 pi over 6 is? Do you remember? Do you remember, Kandura? Yeah, someone said it. What is it? Heck yeah, it's 1/2. So now I have this. Sine of -1, arcsine of 1/2. Okay, on the unit circle again, I'm looking in quadrant 1. Sine of what angle is 1/2? In quadrant 1, pi over 6. At pi over 6, you get square root of 3 over 2, comma 1/2. See, pre-cal doesn't go away, guys. Pi over 6. Oh, look, pi over 6. Cool, right? So the first questions are not calculus. They just want to know if you know pre-cal or if you know trig. Here we go. Oh, okay. This is a double angle. This right here, and I'll give you the definition for both. We did cover them. This is just an angle. Just an angle. So what you really have here is cosine 2 theta. Now, hopefully you remember. Hopefully. Do you remember when we did cosine 2 theta? When we did we? Oh, tell me if this sounds familiar. Because some in my morning class said yes, and some in my morning class said no. Does that look familiar to you? Cosine A plus B, cosine A, cosine B, minus sine A, sine B. Okay, so here's how they derive the double angle for cosine. Pretend that B is an A. Yeah, now look, isn't that 2A? So my double angle formula for cosine 2A is cosine squared A minus sine squared A. OMG. See, because that's cosine times cosine, that's sine times sine. Isn't that cool? You're going to need another double angle in case you get the sine one. So here, let me give you the sine one. Sine of A plus B is sine A cosine B plus cosine A sine B. Relax. We're fine, guys. We're fine. If I switch that B to an A, look what you have. You have sine A cosine A plus cosine A sine A. Oh, look, there's 2 of them. 2 sine A cosine A. Those are double angle properties. I just don't want you to be a robot, so we just derived them really quick. So we just did 2 days worth of notes in like 2 minutes. Yeah, this guy right here, that's sine 2A, double angle. And this guy right here is cosine 2A. So you just got to know those 2 in case they hit you with those 2. Chav, how am I going to do this? Okay, relax. Remember, this is just an angle? This 12, what is sine? This really just means this. Sine of that angle is 12 over 13. That's what it means. Draw a right triangle. Here's that angle. 12, 13. Before you can answer what's cosine of 2 theta, notice that for cosine of 2 theta, I'm going to need cosine squared and I'm going to need sine squared. I guess you can, if you wanted to, you can make this in terms of just sine squareds or cosine squared using the Valentine's formula. But you know what? It's easy enough. I'm going to solve for x. Pythagorean theorem, x squared plus 12 squared equals 13 squared. So x equals the square root of 13 squared minus 12 squared. I think these are easy enough numbers to do. Let's see. 13 squared is 169. 12 squared is 144. 44, 54, 64, 25. So square root of 25, oh, is one of the special ones. X equals 5. We're ready. Here we go. Cosine of 2 theta, well, that's what I have, or cosine of this guy, is equal to cosine squared theta minus sine squared theta. I already have my cosine and sine. Child, what are you talking about? Cosine is 5 over 13. Sine is 12 over 13. It was given to you. The sine one was given. We had to solve for the cosine. So here we go. Cosine squared. 5 over 13 squared. Sine squared. 12 over 13 squared. 5 times 5, 25. 13 times 13, 169. 12 times 12, 144. 13 times 13, 169. And I'll wait. 25 minus 144. 144, 134, 124, then another 5, 119. Negative 119 over 169. That was a lot. That was a lot. That's what we did in pre-cal last year. Did we do this specifically? Oh. This year's group will. I think we probably didn't. No, we should have. Dang, man. I'm sorry, guys. But now we at least expose you guys. Can we go to the next one, guys? We're done. The next are easy. Oh, ask me. What's up? No, I want you to ask me. I'll figure it out. Okay. Do we have any questions, guys? Chavez, you doing all right? For sure? Faux show. Sorry, that was like a burp with a... All right. Derivative of arcsecant. I'm going to put it here on the side. d dx of arcsecant of u equals 1 over u. Sometimes they put absolute value on it, but we don't have to worry because it's being squared. Square root of u squared minus 1 times du dx. We're okay? All right, that's all I'm doing. My u is 3x squared. So don't forget your du dx. The derivative of that is 6x. Are we cool? All right, here we go. Y prime, notice my notation, because they call that y, equals 1 over 3x squared. That's my u. Square root of 3x squared squared minus 1. And don't forget, I'm not done yet, times du dx times the derivative of 3x squared, which is 6x. You're done with calculus. You're just doing algebra. Y prime equals 6x right there over 3x squared. Square root, when I square the 3, that's a 9. When I square the x squared, that's x to the 4th minus 1. It looks like it's almost like that. 6 divided by 3 is... And one of these x's cancel out. So I have 2 over 1x square root of 9x to the 4th minus 1. Are we okay? Let's go to question 5. Oh, no. What do you think, Maddie? You good? Faux show? Faux show. All right. So don't worry. You don't have to write a lot. Just write y equals 5e to the 3x, arcsine x. And I want to take a derivative. What rule do I got to do to take this derivative? Product. Hey, Mendejoyos. Yeah, definitely. Juggling Rodriguez. You're leaving home. Congratulations. Plus 10. Don't worry, miss. I'll record this. I'm recording it right now. So I will send it to you personally. All right, here we go, guys. Derivative. What rule am I using? Product. First, 5e to the 3x times derivative of the second. 1 over square root of 1 minus x squared. They're being nice to me because they're making, it's just arcsine of x, so there it is. Plus the second arcsine of x, so I'm going to write it as sine of negative 1 of x, times derivative of the first. Derivative of the first, itself, 5e to the 3x times the derivative of 3x times 3. There it is. I'm done. Let's make it pretty. Y prime equals 5e to the 3x over square root of 1 minus x squared plus 5 times 3 is 15. 15e to the 3x, arcsine of x. Let's look for that. Here it is. Now, something's going on with the formatting. I printed this out this morning, so something's going on with the formatting, but there it is. That's a 1. So we're already halfway, guys. There's only 10 questions in here. So it's going to be a pretty short quiz. What do you think, Kanduru? Fabulous? You just got to know your little formulas. I guess I'll put it right here. You could always derive it from scratch. You want me to derive this one from scratch? We derived the arctan from scratch last time. We can really quick. All right. Yeah, don't write this down. Just listen. Let's do it because I got some space right here. So let's say I want to find the derivative because some of you guys are, all these formulas come from somewhere, right? So let's say I want to find the derivative of this. And don't just listen, just listen. Chubb, I don't know the derivative of that. Well, we know it's this, right? But let's say we didn't. You would probably do, well, I don't know the derivative of arcsine, but I know that if this means inverse, I know that this means the same thing as sine y equals x. Yes or no? Right? Those are inverses of each other. See? I want to get rid of this arcsine. Okay, well, sine, so there it is. Sine y equals x. And now I can take the derivative implicitly. What's the derivative of sine? Cosine y, but that's not an x, so I put dy dx equals the derivative of x is just 1. Okay, get dy dx by itself. Dy dx equals 1 over cosine y. Chubb, I thought you said it was going to look like this. It does. Come to the side and write side note. And you're going to say, well, I want the derivative in terms of x, not y. So I'm going to write cosine squared y plus sine squared y equals 1. Get the cosine y by itself. So I'll move this to the right and square root it. Well, I guess let's do it one step at a time. Cosine squared equals 1 minus sine squared y. Look, you're already seeing it. Square root. Cosine y equals square root of 1 minus sine squared y. And then there it is. So we're done. And we're just talking about the positive one there. And Chubb, how's that going to help me? It's not. I don't see the answer just yet. Well, look. 1 over square root of 1 minus sine. Let me write it like this. Sine y with the square on the outside. Well, look what I have right here. Sine y is equal to x. 1 over square root of 1 minus x squared. OMG. It's the same. So all of these can be done that way. But why would you want to do that over and over again when you can just... No. Well, we're not robots. We know they come from somewhere. Being a robot means you're just doing stuff without knowing where it comes from. No, well, we did this. We derived arc10, remember? In the notes. No, and I immediately after... I have it recorded. We can go back. As soon as after we derived arc10, we said this is how you derive all of them. It's the same process over and over. Okay. No, we're not robots. All right, here we go, guys. What rule do I need for this one? What rule do I need for this one? Quotient. Y prime equals bottom, derivative of the top. This is the arctan one. 1 over 1 plus 5x close it squared times 5. Chain rule. Bottom times derivative of the top minus top arctan of 5x times derivative of the bottom, 1. All this is over bottom squared. You are done with calculus. Now you're just doing algebra. So let's see what this is. I see a 5x, so y prime equals, I see a 5x on the top, and I see a 1 plus 25x squared on the bottom minus arctan. This is a simple algebra one. You just need a common denominator. All over x squared. Let your answers give you hints. Look at all these denominators here. with an x squared and a 25x squared plus 1. I mean, not that, you'd probably figure it out on your own anyways. Multiply this one here by 1 plus 25x squared over 1 plus 25x squared, because that's the only way you add or subtract two fractions, right? So there it is, common denominator. You got to find a common denominator. So here's what I have. I have 5x over 1 plus 25x squared. And I'm going to distribute this. Don't forget that negative there. I guess maybe distribute the negative afterwards. Minus, and here we go. Arctan of 5x plus 25x squared arctan of 5x all over 1 plus 25x squared. And all this is still over x squared. So catch up to here. Or just follow along. Maybe some of you might be better off just following along. Distribute this negative. And I'm going to keep change flip. Do you want me to do it in 2 steps or 1 step? 2? Okay, 2. 5x over, no, you told me 2 steps. So 5x minus arctan of 5x minus 25x squared of arctan of 5x. All that is over 1 plus 25x squared, and all that is still over x squared. Yeah, I was going to do it in 2 steps, but 1 step, but you guys told me 2. All right, keep change flip. So that means this guy is going to go right next door to that. When you do that, insert parentheses, because some of you guys have a bad habit of not putting parentheses, and then that's going to change your answer completely. So here's my final answer. 5x minus arctan of 5x minus 25x squared arctan, don't yell, that's a demerit. Arctan of 5x, all this is over x squared parenthesis 1 plus 25x squared close. I look for that answer, and it is in there. Just pay attention to these negatives here. That's a negative 25x squared. That's a negative or a minus, and that one's a positive. So here it is. What's up? Did I mess up? Okay. Cool or not cool? Okay. Let's go to the next. Does this help you guys? Do you guys like when I go over these or no? Yeah. All right, we're almost done. All right. Be very careful with this one, guys. Be very careful with this one. What's up? Yeah, go ahead. Your u is ln of 5x plus 7. It's a composite argument property or a composite function. That's your u. So write that down. Let me go ahead and put the rule. Yeah, I'm pausing. d dx of arctan of u is equal to 1 over 1 plus u squared du dx. If you go to Khan Academy and you say, Chop, that's not what Khan Academy says the derivative of arctan is. They say it's 1 over x squared plus 1. Guys, it's the same. 1 over 1 plus x squared is the same as 1 over x squared plus 1. Okay. All right, ready? Okay. Are we ready now? Oh, okay. I'm going to drink some of my beverage. Are we ready? All right, here we go. You guys ready? Here we go, guys. Here we go. Okay, I don't know what that was. 1 over, I'm following this right here. 1 plus, what's my u? Yeah, make sure you include the ln. Parenthesis, ln, open parenthesis, of 5x plus 7, close, squared. Am I done? No, times the derivative of ln of 5x plus 7. What's that?
1 over 5x plus 7.
Good job. Yes. Times 5. Don't forget the times 5. Times 5. There it is. Now we got it. Now we got the chain rule. So this 5 looks like it goes in the top. 5. Over, and put this with, I don't know, maybe put a large bracket here. Or maybe change your colored pencils. Yeah, I'm going to do the colored pencils. Color, blue. 1 plus, parenthesis again, ln, parenthesis again, 5x plus 7, close Let me see. Close that guy, put a square, and then close my blue one. Bam! And I still have this guy, the 5x plus 7. Open another one. 5x plus 7, close. Done. Look for that. And there it is. How are we feeling, guys? Okay. Here we go. We're almost done. We're almost done. Do you guys want me to put the definition of the derivative for arcsine first before I start it?
Yeah.
I don't know that helps. 1 over square root of 1 minus u squared times du dx. What is my u? Because I think that's where you guys get confused all the time. What's your u? So there's a lot of chain rule going on right here, guys. All right, miss. All right, here you go. Y prime equals, and all I'm doing is just following this derivative here, 1 over square root 1 minus, open parenthesis. I'm going to type in what my u is. Here's my u. It helps to write it out. Square root of 2 minus 4x squared, close, put a square on it, times, I'm not done. Now I'm taking the derivative of the square root of 2 minus 4x squared, bringing the half to the front, 1 half, giant parenthesis, 2 minus 4x squared, close it to the power what? Negative 1 half. Am I done? No, chain rule still. Times what? Negative 8x. Good job. Sorry that I have to keep going up and up and up and up. All right. We're done. We're done. Now we're just making it pretty. So let's see. Here's what I see. Go slow. This half and that 8, that turns into a 4. And I see that negative, so that negative 4x is going to my numerator. Negative 4x. There's my numerator. Over, and I'm slowing, I'm going slow. Over, don't worry, we're going slow, guys.
What did we just do? We did the derivative of the arcsine. Okay, yes, now we got it.
Yeah.
We did it like the derivative. Now we're simplifying.
We're simplifying. Yeah, we're done. We're just doing algebra. 1 minus, when you square a square root, the square root goes away, distribute the negative, minus 2 plus 4x squared. Did I get anyone confused with that? I distribute the negative, guys. Let's see, what else do I have down here? Look at this. This, when I bring it down, it's going to turn into square root. So square root of 2 minus 4x squared. I think we're ready. Your laws of exponents comes in. Look, square root, square root. Both of them have a square root, so can I just do one giant square root? Yes. No, not maybe. Yes, we can. They don't have to. Side note, square root of x squared times square root of y squared can be written as square root of x squared y squared.
Oh, I thought you were going to get rid of.
No, just one square root. Yeah. Over square root 1 minus 2 is negative 1. So I'm going to put the 4x squared first. Parenthesis 4x squared minus 1, close. And then I'm going to put this one. 2 minus 4x squared, close. And there it is. That's it. All right. This is probably the hardest question in here. So I'll give you guys some time to write that question down. I don't know why they put question 9 here. Question 10 actually goes back to easy. And it's all relative, right? Because it just depends on your experience level. Question 9 is just a lot of algebra. That's all it is. It's just a lot of algebra. I'll put the derivative of arcsine here in the corner. So while you guys are copying the equation, I'm just going to write the derivative. You don't have to write it. Derivative of arcsine of u is 1 over square root of 1 minus u squared times du dx. All right, here we go. Yeah, I haven't started anything. When I'm doing the derivative of this guy right here. All right, guys, focus, focus. X over the square root of 9 minus x squared. When I do the derivative of that, what rule am I doing? Quotient in combination with chain. Bottom, square root of 9 minus x squared times derivative of the top, 1, minus top, x, times derivative of the bottom. When I take the derivative of the bottom, 1 half, parenthesis, 9 minus x squared, close it to what power? Negative half. Am I done? Times what? Negative 2x. I like to put parentheses so I don't get confused that it's subtracting. Close all that. There it is. Bottom times to the top minus top times to the bottom. All over. Bottom. Yeah. 9 minus x squared. Or let me show it because I don't want you guys to be confused. Square root of 9 minus x squared. Close it squared. The square root is going to go away. We're not done yet. We just did the derivative of that one. That's all we've done. Minus. That minus is this minus. And the derivative of arcsine, I'm just following this rule right here. 1 over square root 1 minus parenthesis x over 3, close it squared, times, what's the derivative of 1/3 x? 1/3. There it is. There's my statement. Don't worry, I'm going to make it pretty. You're done. Everything else is algebra. It's pretty heavy algebra, guys. It's pretty heavy. If you give this to an algebra 1 student and just told them to simplify, maybe they'd cry. I don't know. Y prime equals, here we go. I'm going to go slow and ask me questions on what doesn't make sense. Square root of 9 minus x squared. I haven't done anything yet. Minus, and let's see. That 1 half and that 2 go away. I see this in the numerator. X times x is x squared. So x squared over square root of 9 minus x squared, and all this is over. Yes, plus. Thank you, miss. Over 9 minus x squared minus, and then I see 1 over 3 square root of 1 minus x squared over 9. There we go. We're in good business now. Do you guys want me to mess? Which one do you guys want me to mess with? That's the sense of version. The one on the left or the one on the right? Okay, so we're going to mess with the one on the left. We don't even look at the right. We mess with this one. I need a common denominator in the numerator if that makes sense. Cool or not cool? So I'm going to multiply this term here by the square root of 9 minus x squared over the square root of 9 minus x squared. Square root times square root is? The square root goes away. 9 minus x squared over square root of 9 minus x squared plus x squared over square root of 9 minus x squared over 9 minus x squared. And I still have that minus is that minus. And I guess I'll write it just for clarity. I was tempted to mess with the right one, but I don't know if we can do both at the same time. So we'll just do one. I think we probably could. But I have the same denominator in the numerator. So I can just add those two dudes up. The x squared and the negative x squared cancel. Do you guys see that? And keep, change, flip. Look, I have a 9 minus x squared in the denominator of my denominator. So what's a half plus a whole? 3 halves. So here's what I now have. And I'm going to bleed into the next one, but that's okay because the next one has a lot of room. Let me go back to red. Y prime equals 9 over, parenthesis, 9 minus x squared to the 3 halves. And now we're going to mess with the one on the right. 1 over 3 square root. That one, turn it into x squared over x squared. X squared over x squared. 9 over 9. Sorry, guys. I have some space over here in the corner, so I'm going to change my color real quick so no one gets confused. Let me change to a default color that we haven't used. You see this right here? Look at this, guys. Square root 9 minus x squared over 9. What's the square root of 9? So I can write this as 1/3 because it's a denominator. Square root 9 minus x squared. Or put the square root of 9 minus x squared in the numerator and the 3 in the denominator. So notice I already have a 3 there. So this right here is going to turn to this. So let's see. I'm going to rewrite it again. Y prime equals 9 over 9 minus x squared to the 3/2 minus 1 over 3 square root of 9 minus x squared. And this 3 here specifically is this one right there. This 3 is that 3. Yep. Yep. We're so close. Don't worry, we're not going to use up all this space down here. So let's go ahead and bring it down to right here. Y prime, let me go back to red. Y prime equals 9 over 9 minus x squared to the 3/2 minus 1 over square root of 9 minus x squared. So close. In order for me to subtract those two quote-unquote terms, I need to have a common denominator. So the one on the right-hand side, I'm going to multiply by 9 minus x squared over 9 minus x squared. Does that make sense? Because that's a whole. A whole plus a half is a square root of 3, is a 3/2, sorry. So here's what I have. Y prime equals 9 over 9 minus x squared to the 3/2 minus 9 minus x squared. We'll distribute the negative in a little bit. 9 minus x squared to the 3/2 equals, we finally got our answer. A half plus a 1. Yeah, this is a half.
Oh, because 1 plus a half.
Yes. Distribute the negative, guys. What's 9 minus 9? So you just have x squared, it turns positive. Yeah, negative times the negative is positive. Over 9 minus x squared to the 3/2. And that's it. Look for that answer. Yeah. Last, what? Right there. We have to do a whole bunch of algebra. All right. We're not going to use all this space for number 10, so relax. So here we go. Number 10. Let me zoom out first. Let me write it right here. Y equals arctan of e to the 5x over 2. Sometimes I like to write those as 1/2 e to the 5x because it's the same thing. ddx of arctan of u equals 1 over 1 plus u squared du dx. Y'all ready? Yeah, this one's not as bad. This one's pretty straightforward. Y prime equals 1 over 1 plus parenthesis e to the 5x over 2, close it squared, times the derivative of e to the 5x over 2. So the derivative of that is itself, so e to the 5x over 2 times what? Times 5. Chain rule. Right? No, because there's no variable in the denominator. This is a constant. You could have rewritten it as 1/2 e to the 5x. Yeah. Yeah. You could if you have a constant, you could have always rewritten it as 1/2 e to the 5x. All right, here's what I see. What do I see? The 5e to the 5x goes to the numerator. 5e to the 5x over 1 plus e to the 10x, your exponent rules, over 4. They don't have it written like that. Oh, yeah. All this by 2. They don't have it written like that. Let's distribute the 2. So let's see. 5e to the 5x over 2 plus e to the 10x over 2. Okay, catch up to here. I'm going to go ahead and do a common denominator in the denominator. Does that make sense to say that? So I'm going to turn that 2 into a 4 over 2. And then look what I have now. 5e to the 5x over 4 plus e to the 10x. This is over 2. Keep, change, flip. What's 5 times 2? So there it is. We got our answer. 10e to the 5x over 4 plus e to the 10x. Look for that answer. And there it is. All right, guys. We are done.